Hello students, in previous lecture we have studied about 1 and on to function and also what are invertible functions. Today we will do some applications on the topic of 1 and on to function. So this is exercise 1.2 of NCERT. Question number 1, show that the function f such that r to r defined by fx is equal to 1 by x is 1 and on to, where r star is the set of all non-zero real numbers. So solution, fx is equal to 1 by x, and what that indicate, its domain is set of non-zero real numbers, and codomain of this function is also set of non-zero real numbers. So fx is given in the form of 1 by x, therefore if we can write if fx1 is equal to fx2, this implies we have to substitute x1 instead of x, so 1 upon x1 is equal to 1 upon x2. This implies x1 is equal to x2. Therefore, it is 1, 1. What we have shown, if f of x1 is equal to f of x2, that means 1 upon x1 is equal to 1 upon x2. That implies, because numerators are equal, so definitely the denominators will be equal. X1 is equal to x2, therefore it is 1, 1. Why? Because every element of A has unique image in B, and if the elements are different, the images will be different. If the elements are same, the images will be same. Therefore, it is 1, 1 function. And fx is equal to y is equal to 1 by x. This implies x is equal to 1 by y. This implies f of 1 by y is equal to y. Therefore, it is onto. Why? Because x, by proportionality, x we brought it to the left side, so that becomes 1 by y. Now if we will substitute the value of x as 1 by y, we will get as y. So why it is onto? Because for every while in, you can see r star, there is pre-image as 1 by y. That means there is no element in the codomain which is not having, there is no element in the codomain which is not having the pre-image in domain. Therefore, this function is onto. Hence, we can write over here. Hence, it is 1, 1 and onto. Now, second part, this was the first part. Is the result true if the domain r star is replaced by set of natural numbers n? N always represent the set of natural numbers. So we have to check it now. If codomain remains r star but the domain is replaced by n, so therefore if r star is equal to n as domain, this implies it is 1, 1. Why? Because if 1 by 1 is not equal to 1 by 2, that implies 1 is not equal to 2. So therefore it is 1, 1. every element has unique image. Now, and different image. Every element of n has different image in R star. Now, for onto, we can see what we will get. F of 1 is equal to 1 by 1 is equal to 1. F of 2 is equal to 1 by 2. F of 3 is equal to 1 by 3. Therefore, what is codomain? Codomain is a set of 1, not codomain, but it is a range, set of range. Therefore, why? Because whatsoever we will substitute the value of x as domain and we are getting the value of y, that becomes range. So it is 1, 1 by 2, 1 by 3 and so on. And what is this? The values of this will lie between what? Between 1 or we can between or less than equal to 1 or less than equal to 1. That means this set 1, because 1, 1 by 2, 1 by 3 and so on, this set is a subset of R star. And we have seen if there is any element in the codomain which is not having the preimage, then the function is not onto function. Therefore, this is not onto. So we have seen in this problem that if we will replace the domain of the function from non-zero real numbers to natural numbers, then it will be 1, 1, but it will not be onto. Now we'll take the second problem. This is question number 3 of exercise 1.2 from NCERT book. Prove that the greatest integer function f such that r to r given by fx is equal to greatest integer function x is neither 1, 1 nor onto where x does not denotes less than or equal to x. This is fx is equal to x, greatest integer function. Greatest integer function. What that denote? The number is less than or equal to x means we have to take the greatest integer. Now we can see what is f of 1, that is equal to 1. What is f of 1.1? What is the value of f of 1.1? We have to substitute here 1.1, greatest integer. So what is the greatest integer in 1.1? Because integers are 1, then 2, 3. So that means it is always equal to 1. F of 1.3, that is also equal to 1. Therefore, what happens? For x1 is not equal to x2, f of x1 is equal to f of x2. We are substituting the values of x different values we are substituting over here, that is 1.1, 1.3, 1.2, but the value of fx we are getting, that is same, that is 1. Therefore, this implies it is not 1, 1. Now, second part, we have to show that it is not also onto. What is the value of f of 1.5? That is equal to 1.5, and this is equal to what? 1. That means what is the range of this function? What is the range of fx? We can write it like this. This is equal to what? Set of integers 1, 2, 3 and so on. But what is the code main of this function? The code main of this function is real number. The code main of this function is real number. So this implies R is a subset of code main. It is not equal to, but it is a subset of code main. When it is a subset of code main, that means there may be some elements in the code main which are not having the pre-image in the domain. This implies it is not onto. Now we'll take question number 6, that is the given set A is as 1, 2, 3 and B is 4, 5, 6, 7 and F is given as what is F? F is 1, 4, 2, 5, 3, 6. What that means? This implies f of 1, when we will substitute the value of x as 1, then this is 4. What is f of 2? That is equal to 5. What is f of 3? That is equal to 6. You can write x over here. So this implies if x1 is not equal to x2, we have taken different value 1, 2, 3, then f of x1 is not equal to f of x2. See, when we have taken x1 as 1, x2 as 5, both are not equal, and the values whatsoever we are getting, that is 4 and 5, they are not also equal. So that means this function is 1, 1. Therefore, f is 1, 1. This was required. Let A and B, B is 4, 5, 6, 7. So we have shown it that it is not 1, 1. But is it a onto function? It is not required in this question, but I am asking that it is onto function? No. Why? Because its range is 4, 5, 6 and that is subset of code main 4, 5, 6, 7. That means it is not onto. But this is not required from us. Now we will take second problem. Next problem is question number 10 of 1.2. In this, A is given as set of real number except 3 and set of real number except 1 is the code main, and fx is defined as f of x is equal to x minus 2 by x minus 3 for x1 is equal to x2. What is f of x1? x1 minus 2 upon, we can take it as x1 minus 3 and x2 minus 2 upon x2 minus 3. We have substituted the value of x first as x1 and second as x2. So if f of x1 is equal to, we can write it over here. If f of x1 is equal to f of x2, then this implies x1, we have substituted the value of x as x1 and here x2. So this implies Now make cross multiplication. X1 minus 2 into x2 minus 3 is equal to x2 minus 3 into x1 minus 3. So this implies x1 x2 minus 3x1 minus 2x2. This is equal to x1 x2 minus 3x2 minus 3x1. So this implies this cancelled. So what we are getting over here, minus 3 x1 minus 2 x2 minus 3 x2 and minus 3 x1. Okay, so transpose the terms. X1 minus 2 into x2 minus 3, x2 minus 2 we have written here by mistake as 3. So now this is x1 x2 minus 3 x2 and minus 2 x1. So now transpose the terms with x2 on one side and with x1 on other side. Then what would you get from here? This is 3x2 minus 2x2 is equal to minus 2x1 plus 3x1. We have transposed this term to right and this term from right to left, and when we will transpose the term, then obviously there will be change in the sign of term. So this is x2 is equal to x1. Therefore, f of x is 1, 1. Why? Because if f of x1 is equal to f of x2, we have shown that x1 is equal to x2. Hence, the different element of y is having different image in B. A in B. So now, next is we have to show that onto. So let y is equal to fx is equal to x minus 2 by x minus 3. What is onto? If there is no element in B which is not having the pre-image in A, so this implies y into x minus 3 is equal to x minus 2. So yx minus 3y is equal to x minus 2. So transpose the terms x on the left side and terms with y on the right side. So we can take x as common. So when we will take x as common, so it would be y minus 1 and this is 3y minus 2. So this implies x is equal to 3 minus 2 by y minus 1. We have seen that if y is equal to fx, then this is equal to this by cross multiplication. Y to x minus 3y is equal to x minus 2, and we have seen that x is equal to 3y minus 2 y minus 1. So therefore x is equal to 3y minus 2 upon y minus 1. This implies x is not equal to 3. So what we have seen? X is not equal to 3. For, therefore, f of 3y minus 2 upon y minus 1 equal to y. So what that indicate? That indicate every element of y is having pre-image in every element of B. The sets are A and B. Every element of B is having pre-image in A. So, for every y in B, there is pre-image in A. This implies it is onto. Hence, this function is 1, 1 and onto. We have seen that if we will substitute this value, then what will you get? We will get as y. That means every element, every y in B, there is pre-image in A. So we have done 4 problems from this exercise. Rest of the problems you will try by yourself. Thank you.